Yeah. Okay, so this is our our practice internal. It's called Birdstrike. Look, at the start of it, you just have to actually read what's going on. So jet flies into a flock of birds. There's a probability that the engines will fail due to bird strike. And there's 4 engines, and each engine, and that's something you got to think about. Each engine is struck as 0.3. Look, if you are reading through this, I suggest you highlight the important things. So we have 4 engines, and we also have a probability that the engine is stuck is 0.3. Although we're stuck for time here, Tom, you're on candid camera. Although we're stuck for time with this internal, it's really important that you figure out how to use this probability. So if it's out of a decimal point, it's like having, if it's 0.3, we can put it into 10 grids, and we can say that if it's 0.3, that's like saying 3 grids out of 10 are used. So if we can color that in somehow, there we go. So that means that that is the probability visually of showing when an engine is struck and broken. So even if you do this at the start, it just is a good way of visualizing that probability and also what you're going to put for the formula. So this is the first section. The first section is about the engines, and here are these conditions. So we have 4 engines. If 2 of them are affected, we have to do emergency landing, and there's another probability that we have to sort out. But if 3 or more engines are out of action, the plane will crash. All right. So again, we've took a lot more time just to go through it because understanding it's pretty much the essential thing. If you don't understand it, but you can still do the maths, you're not going to get anything. All right, so we're designing it, and we just have to, we scan through here. Most of this is the same. You got to do a trial. We got to repeat it. And then we have to determine the probability that the plane will crash. So this is our, what we call our successful trial. I know successful in this case is when a plane crashed, but this is what we're looking out for. That's what the term successful is. Yeah, and we'll go into assumptions. All right, so in the very first part, we're going to write our title. I'm not going to write title, but for tool, that's weird font. Okay, so for tool, our very first thing is aim. And look, you can, if you just memorize it in flashcards, you can just set it up like this. So aim is to determine the probability of a plane crashing. All right, tool is to do this. I will use the formula. What formula are we going to use? So there's different ones. I'll do both of them. Ran hash times 10 plus 1 if you got a budget as calculator. Otherwise, it's ran int hash 1 to 10. All right, and that's our formula. And then you can say for the engines, I get 1 to 3. The engine will break. Otherwise, it will be fine. And actually, when you're explaining it, you can actually put this in here because it's a really good way of demonstrating the probability. Also, there's another probability. The probability is if there was only 2 engines broken. It has a 70% chance of doing a safe landing, making a safe landing. So in terms of numbers, and we can actually just copy this, in terms of numbers, that is fine, and then this is gray. Cool. So we can say 1 to 7 is safe landing or crash landing, but still safe. And then 8 to 10 is fail. And we can actually do this over here as well. Since there's 30% chance of an engine failing. And so that means 1 to 3 was failing over here, engine fail. Other than the rest of it, 4 to 10 is engine is fine. Cool. So that's what we need to do for tool. Look, the next part we have to do is trial. So we have to think about what makes it across. So in this trial, we will be simulating 4 engines and then determining if there is, guys, let's be quiet, if there is a safe landing. All right, so a successful trial. So you have to say what is in the trial, what makes up the row, as well as what is successful. So a successful trial is when a plane crashes. So you got to put an example. For example, and this is where we might have to set up what it looks like. So I'm going to just insert a table. We've got 4 engines plus maybe a crash landing there. Oh, and we just need to insert below. So if we have it as eng 1, eng 2, eng 3, eng 4, we may have to do a crash landing, but we might not, and crash or safe. So if we had these numbers, an example, and maybe for you, you might want to do the simulation first and then just leave space to do these examples. But if we have engine being 5, that means it's fine. We might this will have to be my tick for now. If we get a 2, that means that engine has failed. If this is a 7, that's fine. And let's do another one when this is another 2, and that means we've got 2 engines broken. So in these conditions, if you have 2 engines broken, you've got to simulate it again to see if there's a crash landing. All right. So for this, if you get an 8, 9, or 10, that crash landing was a fail. So if I got 10, that means it was a fail. So that one was a crash. All right. So, whoopsie daisy.
How much would you do for that? Just do 1.
You would just do 1 and you make it up because you're just showing what it looks like for a successful. And an unsuccessful, I know it's a bit ironic, but an unsuccessful trial is when it doesn't crash. All right, and that's, again, you can just copy out that, and we just do it, let's say, when we have only 1 engine braking. So if we only have 1 engine braking, that means in the conditions that it's fine, it's safe. All right, and the last 2 things we need to say is that this will be repeated. For me, because I can do it on Excel really fast, I can say 30 times. You'll repeat this 30 times. And we also just have to say each trial is finished when we have determined. So it's how do you know that row is finished? Determined the state of each engine and whether it was crashed or not. This will be repeated 10 times, 30 times. To actual part of the simulation. Now I'm going to cheat and just use Excel. So in these Excel formulas, you might be used to it. This is actually the same formula as you have in your, kind of similar to your calculator. I'm just doing a random number between 1 to 10. I'm doing it for, there's columns of engine 1. I'm doing it for columns of engine 2, 3, 4. And if there are 2 engines that are broken, I also have to do crash landing over there. And I've just put a condition that it already tells me if there's an engine that is broken or is safe. So I go across. I'm doing this. This is me doing it 30 times. It's a lot quicker than you doing it 30 times. And I just made it so it doesn't change. Yeah, and I guess you guys wish you could do that in yours. So this is me doing it, and it's actually programmed to do ticks and crosses. So if there's 3 ticks like this, it's safe. I'm going to just have to do S. S for safe. Safe. Over here, it means we have to do a crash landing one because we have 2 engines that are broken. So we've got to simulate it again for pass or fail over here. So 4. Now 4 means it was safe because it was from 1 to 6. And this is where your tool really is handy because you can just quickly check whether it's safe or not. So the crash landing was fine. It was safe. Yeah. Let me write, please. There we go. Not allowing me to write there. Safe. Cool. And this one, it was safe. Safe. So I've got this. I'm going to do a bit of a cheat again. I'm going to count if this range has the word F in it, because that was what I had for fail. It failed 4 times. And to figure out the probability, we do the successful divided by the total amount. So I know it's 30. And let's times it by 100 as well as a percent. For your report, you have to have something like this. I'm just going to do it down. So I'll say C table. Whoops. C table. So it failed, well, crashed 4 times. That means it's 4 out of 30, which is equal to 13.33%. We do have to finish this off as a sentence. This could be results. So the sentence is that a plane traveling through these circumstances is 13.3% likely to crash. That's pretty frightening. Cool. So for achieved, that's all you need to do. Let's go take it up to merit. Now, there's kind of like a disclaimer. I was talking about it a bit before there. That is not the actual probability. That's just our it's like our sample. Okay? So we have to make a disclaimer, because just like someone might get 0%, that's your disclaimer saying, actually, don't take my word for it. I'm pretty lucky to get 0% crash. You could get a different result. So we say this is only an estimate. If I were to do it again, I would get different results. All right, so that's your disclaimer. It's like, don't take my word for this. You could get different things. And you can say, if I took a bigger sample, I would expect to have a more accurate probability. All right, that's just like we had for our inference. Now, this is where you go to merit as well. These are the assumptions. So what are you assuming in this simulation? One thing that we can assume is that the engines have the same probability, which it might not, all right? But we're assuming in this simulation that each engine has 30% chance of failing. Although the position of the engines, the size of the engines, where these birds are, may actually mean that that would be different. So that's an assumption that we're assuming all engines have the same probability of failing. In statistics of probability, that's called mutual independence. And this might not be the case in real life. All right, any other probabilities? Any other assumptions that we're thinking of? Assumptions, there's one for time usually. Time, you're assuming that these conditions stay constant, all right? Because it might be only birds do it at the start when they look closer to the ground. That would make sense, but in this case, we just assume that these conditions stay there the whole time. We're also assuming weather. That could be one, because birds are the thing that's affecting this, and if birds are affected by weather or even time of day, that would change whether there would be any birds actually hitting the airplane. All right, birds don't change with regard to weather or time of day. Cool. So for excellence, the last bit is to kind of redesign it. I'm not going to go through that, but I'll just make some suggestions.